Our next unit is all about trigonometry, and you learned a little bit of this in geometry. You learned about sine, cosine, and tangent, so I'll just give you a quick review of that. Sort of the way that we remember this is we think of sine as the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent, and we remember SOHCAHTOA. So what's really happening is we're making ratios of sides of a triangle. So let's say that we were going to talk about this angle down here, and it's pretty common to call an angle theta. It's a Greek letter that we use to stand for an angle measure. And then maybe I'll just make up some side lengths. Maybe this one could be 12, and this one could be 9. And even if they only gave you two of them, you could figure out the third side with a little Pythagorean theorem. It's important to know that the hypotenuse is always going to be the C value. Today's a calculator day, so if you don't have one, you should grab one. 12 squared plus 9 squared, 225. Square root would be 15, yeah? So that means our hypotenuse is 15 on this one. So then if we wanted to set up the trig ratios, say we wanted to use sine of that angle theta, sine is going to be opposite. Now that depends on your angle. So if we're at this angle, over here is opposite. And next to is another way to say adjacent, and this is always the hypotenuse. We'd have to change those labels if we were talking about the other angle, because then this would be opposite down here, and this would be adjacent over here. So if we're doing sine of theta, we're talking opposite over hypotenuse, and you can reduce that, divide by 3, 4/5 would be the sine ratio. Feel like this isn't too bad. You've done this before. Adjacent over hypotenuse, reduce it. Tangent of theta, opposite over adjacent. So we have these kind of random fractions. Now, kind of the cool thing I think is that even if I shrunk up this triangle big time, like let's say I shrunk it up by 1/3. If I made another triangle and I shrunk it up by 1/3, this angle wouldn't change. That would still be angle theta. Like, can you see how that looks the same size as that? But if I shrunk it by 1/3, this would be 3, 4, and 5. But the coolest thing about sine, cosine, and tangent is, look, sine would still be opposite over hypotenuse. It would have been this 4/5 right away. We wouldn't even have to reduce it. So you can do trig ratios on any right triangle, and that angle is really, you know, no matter what similar triangle you're talking about, you're still going to get the same trig ratio. Now, it says that we're going to extend this today, and that's because there's actually 3 more trig ratios that you've never heard of. One of them is called cosecant, secant, and cotangent. So let's just pretend we're on that same triangle as we did before. So we've got a 9 and a 12, and the Pythagorean theorem gave us a 15. Now the deal with cosecant is it's just the reciprocal of sine. So you know how sine was opposite over hypotenuse. Cosecant is going to be hypotenuse over opposite. Secant is the reciprocal of cosine. Cosine is ca, a over h, so this is going to be h over a. Cotangent, this one's the easiest one because it's the inverse, sorry, not the inverse, the reciprocal of tangent. So instead of toa, it's a over o. And I don't have a cool thing to remember this because 2 of them start with C, and it just, so you just have to remember which one goes with which. So cosecant, sine. Yeah, so let's do these ratios. So the abbreviation for cosecant looks like this. Cosecant of theta would be the hypotenuse over the opposite, which, can you see it now? Is just the reciprocal of what sine of theta was. Secant, we actually wouldn't have to go through this since we already know what cosine is, but let's do it anyway. So secant would be our hypotenuse over our adjacent. And cotangent, here's our abbreviations, cotangent of theta Instead of 12 over 9, it's 9 over 12. And that's pretty much every combination of fraction we could make out of this triangle. It's going to be a huge thing in this unit that you remember your 30, 60, 90 and your 45, 45, 90 triangles. And the way that has always worked best for me is I just remember the basic 45, 45, 90 has a 1, and if you do the Pythagorean theorem, you're going to wind up with a square root of 2. These are always going to be the same because that's an isosceles triangle. And then on the 30, 60, 90, it's 1, 2, square root of 3. 1, 2, square root of 3. And since 2 is the biggest of those three numbers, it has to be the hypotenuse. The hypotenuse is always double that shortest leg. So you're going to wind up doing sine, cosine, and tangent, and the other three on all of these. And some teachers are going to have you memorize these. I think if you can come up with them fast enough, that you won't have to memorize them. That's my opinion. So I'm just going to do sine, cosine, tangent. I'm pretty sure you could reciprocalize those. That's not a word. You could find the reciprocal of each of those and do the other trig functions. So sine of 45 would be opposite over hypotenuse. Cosine of 45 degrees, adjacent over hypotenuse. And tangent 45, opposite over adjacent. And we're going to actually want you to write all three of those slightly different. So remember, no square roots on the bottom, so we'll do what's called rationalizing the denominator. So your final answer for sine of 45 is going to look like this. Square root of 2 over 2. Square root of 2 over 2. Also for cosine. And tangent is just 1 for 45 degrees. And like I said, even if this was twice the size of this triangle, the angles would still be the same and these ratios would still simplify to the same. We might as well write out these other ones. Like I said, if you wanted to, you could memorize all of these. If you have limited storage space like I do, then you just have to be able to come up with them real quick. So we're talking the 30 this time, so opposite over adjacent. That one's nice and simplified already. Cosine of 30, adjacent over hypotenuse. I think I just said the wrong thing on that last one, didn't I? Yeah. Tangent of 30, opposite over adjacent. And that one's not going to fly because it has that square root on the bottom, so we'll just rationalize that denominator. And our final answer on that will look like square root of 3 over 3. Okay, so 6 things you could memorize. And let's add 3 more because you're going to have to be able to come up with these too. Now this is not a calculator thing. There's going to be 2 parts to your test and you won't be able to use a calculator for this type of thing. So you're going to have to be able to draw this triangle. If you can draw the triangle, you can come up with these using your SOHCAHTOA. I don't see a lot of point in memorizing it. You're probably going to have a trig teacher someday that will make you memorize it. Tangent, square root of 3 over 1. So just square root of 3. So 9 things you could memorize or come up with quickly. I don't care which one you do. Okay, sometimes it's not a 30-60, not a 45-45-90, so that's where your calculator is going to come in. On a problem like this, I would want you to find the other stuff. Like, could you find this angle right here? Well, if you knew that the 3 angles have to add up to 180, you'd probably come up with this has to be a 20-degree angle. So solving the triangle means finding the other side. So if you temporarily want to call, let's say, this one x and this one y, then we can set up some trig ratios to solve that. So if I wanted to find, let's say, x first, I'd probably use the 70 because I know I didn't screw that one up. It was already printed. So if I want to find x, then I'm dealing with the opposite is what I'd like to find. I have opposite. I know the hypotenuse. If I want the opposite and I know the hypotenuse, I'm thinking I should use sine. Sine of 70 equals x over 15. Multiply both sides by 15. Now you're going to want to make sure you're in degree mode. Otherwise this is not going to work for you. 15 sine 70, 14 point, I guess 1, 14.10. Okay. Now if you keep that number stored in your calculator, you could do the Pythagorean theorem to find y. I think that's a good idea, but let's keep that number stored in our calculator. Don't try to type it all in again. So I'm going to go that 14.10 squared, which actually when you type it in, can you find where it says answer on your calculator? So I'm going to take that answer plus y squared equals 15 squared. So I'm going to wind up doing 15 squared minus that previous answer squared. If you hit second negative, you'll get that on your calculator. I get 26 point something or other. I take a square root, and I get 5.13. Not sure how much different that would have been if I didn't use that answer trick, but I know that's as good as it's going to get. I could have done another SOHCAHTOA to get the 5.13, but that works just as well. The only reason I'm doing one more example of this is because sometimes people get confused when they are not given the hypotenuse. So let's just talk about the hypotenuse on this one. If I want the hypotenuse, I want to use this angle because it's already printed. That means I know the adjacent, and I wish I knew the hypotenuse. I'm seeing a ka coming through. Cosine of 51 equals adjacent over hypotenuse. Now some people get confused when the x is on the bottom. Maybe the best way to go about this is think about cross multiplying. So x times cosine 51 equals 1 times 7. You're going to wind up doing 7 divided by cosine 51. And that'll be your x value. 7 divided by cosine 51. I got 11.1-ish. Feet, inches, I don't know. I would also want you to find this other angle and find this other side, but I just wanted to do a quick example that showed you how to find it if the variable's on the bottom. All right, most of these are pretty easy to type in your calculator. Hit sine 25, making sure you're in degree mode. Cosine 65. Is that weird? That's actually why these are related. Did you ever listen to them? Sine and cosine. Because if you're using complementary angles, you get the same ratio. Little factoid. Tangent. So that types right in, no problem. Now you don't have a cotangent button, so that's what we need to talk about. In order to type that into your calculator, you're going to type in 1 over tangent 65. Because that's like the reciprocal of tangent 65, and that's what cotangent is. So 1 divided by tangent 65. And I planned it that way because I wanted to show you again that if you have complementary angles, tangent and cotangent are the same ratio. That's why they're named that way. Secant and cosecant, can you guess what's going to happen if you use complementary angles? Honestly, you don't need to know that. I just think it's interesting. So when you're typing in secant into your calculator, you're all 1 over cosine 25. When you're typing in cosecant, 1 over sine 65. So it's going to be really important that you remember which one goes with which. Let's see if my pattern holds. It sure holds. Here it is. 1.1034. Secant and cosecant are related in that way. I hope you get the idea. You can try these other ones if you'd like. Now, what's kind of weird is you could never make a right triangle with a 325-degree angle, and somehow it winds up coming out with an answer, and it's negative, and that makes no sense to us yet. But it will by the end of these couple of weeks. 1 divided by cosine of 50. 1 divided by tangent 33. And tangent 180. Seems like that doesn't make any sense either, right? How are you going to make a right triangle with a 180 degree angle in it? Cosine of 360 is 1. Why? We'll see. The big takeaway, you have to know cosecant, secant, and cotangent, and you have to be able to work with 30, 60, 90, 45, 45, 90. So any way you see a 45, 45, 90, you should be able to go 1, 1, square root of 2. 1, 1, square root of 2. Or if I really throw you a curveball, 4, 4, 4 square root of 2. 7, 7, 7 square root of 2. Remember, the ratios are going to come out the same, even if it's some other crazy triangle dimensions. And on a 30, 60, 90, do you remember the numbers of choice? 1, 2, square root of 3. 1, 2, square root of 3. Can I mess with you? 9, 18, 9 square root of 3. 12, 24, 12 square root of 3. So that's a little geometry coming back. Thanks for watching. Best of luck. We'll talk some more on Monday. Thanks.